Okay, so Thursday and Friday we talked about all the log signs, right? 3 cases we can use the log signs to solve an oblique triangle. Name one of them. Angle, angle, side. Name another one. Angle, side, angle. And then our side, side, angle, ambiguous case. Okay? Now, we talked the other day about how angle, 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 there are an infinite number of solutions that triangle could be. We're not going to be able to solve that out. All right? But there are 2 additional cases we need to talk about that involve the law of cosines. As I switch slides, maybe think about what those would be. What are the 2 cases we haven't talked about yet? Okay? Before we write that down. Okay, so the law of cosines. What are 2 cases that we haven't looked at as far as given information?
Side, side, side.
Side, side, side. And one more. What? We've looked at 2 sides with an angle not in between. 2 sides with an angle in between is a case for law of cosines. Okay? So if this is the set of given information, either side, 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 or side, angle, side, then we need to use the law of cosines to solve for our sides and angles. Okay? Here is the law of cosines. This may look familiar to you because you did see it in Honors Algebra 2. Or for some of you, Algebra 3, if that's the route that you took. So when you look at this formula, you notice that all 3 sides are present. Okay, a squared, b squared, and z squared. Okay, so it starts off a lot like the Pythagorean theorem, but then there's a little bit more to it. Okay, so a squared equals b squared plus c squared minus 2 times b times c cosine of a. So a couple things I want you to notice. These 2 sides right here match these 2 sides multiplied to the cosine. And whatever the angle is right here matches your loner side on the other side of the equal sign. Okay? Now, I have rearranged it to where we have b squared and c squared. I don't think that you need to write all 3 of these down. If you need to, that's fine. But what I hope that you'll be able to do is just know that whatever side is here matches the angle and the cosine, and then the other 2 sides fill in the rest. Okay. Since all 3 sides of the triangle are present, okay, that makes it nice for our side, side, side case. All right, and then for our side angle side case, that 3rd side is what we will be finding. So we're going to do a few examples. I can't remember how many. We're going to do 2 examples, 1 for each, and then I have one more area formula to show you. Okay. Now remember, the whole point of us doing this law of sines and law of cosines, we want to solve for sides and angles of oblique triangles. Okay. If you don't have a picture, make sure you draw one. So here we go. Here is our first example, first of 2. Try your triangle so you can identify what type of information you have. our given information is what? Side angle? Side angle sine. Okay, that angle is in between the sides. So it's important to identify that as side angle side. Since we have side angle side, we know that we need to use the law of cosines. Okay? Now, you probably assumed that that's what we would do because I'm teaching you the law of cosines. But remember, tomorrow and Wednesday, you're going to have to decide when to use which. Alright? So, the law of cosines formula, as I mentioned, uses all three sides. Since we do not know side A, that's the one that we're going to solve for first. So we're going to set this up. A squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. Okay, now let me pull up my calculator here. When you're doing this, okay, don't type things in just one at a time and hit equal sign 4 times, okay? Whatever is on the right side here, put it in all at once. We have 3 squared plus 10 squared minus 2 times 3 times 10 times the cosine of 55. Okay? If you type it in all at once, you're not going to mess up any of the order of operations as long as you press all the right buttons, okay? Type it in how it's written. Now, a squared equals that number in my calculator and in your calculator. First of all, do you agree with that number on my calculator? You type it into yours. Yes or no? Yeah? Brandon, that's not you got? You know what? I'm in radian mode. Every time I close the calculator out and then open it back up, it defaults. So let's try that again. 74.585, blah, 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 blah. Okay. So now a squared equals that number in my calculator. What do I do to get a? Okay, so just in your calculator, square root, second answer, and side A is 8.6. All right. Now we need to solve for the rest of the triangle. We need to solve for angle C, and we need to solve for angle B. Thoughts on which one we want to do first? No thoughts? No one cares? Okay. We'll just go alphabetically. We'll find angle B. Okay. So if we are going to find angle B using the law of cosines, we need b squared to be that lower side on the left side of our equal sign. So we need to say b squared equals a squared plus c squared minus 2 times a times c times the cosine of angle B. Okay, we have some work to do. We first need to get the cosine of B all by itself. So then we can do inverse cosine in our calculator. I urge you, be very, very careful with your order of operations, okay? Now, I understand that a lot of us are just gonna use our calculator, and that's good because I don't want you to, like, get any rounding errors, okay? So let's talk about what we need to do, okay? What do we need to do to solve for the cosine of b? Do I need to add all of these numbers together? What? Can I add 8.64 squared plus 10 squared minus 2 times 8 times 10? We can't. This negative 2 times 8.64 times 10 is attached to the cosine of b. Okay? So what we first can do is we can figure out what 8.64 squared plus 10 squared is, and those two can be subtracted over. Okay? So my first job is to take 3 squared, and I'm going to subtract over 10 squared and 8.64 squared. Now, I'm going to write it down. I don't care if you write it down or not, but please leave it in your calculator. Okay? Then, my next step to solve for the cosine of b would be to divide all of this over. So what I would do, if I were you, I would leave this in my calculator, and I would hit divide. Please open a parentheses, because you're dividing by all 3 of those numbers multiplied together. We are dividing by the quantity negative 2 times 8.64 times 10. Okay, so we get in our calculator 0.9586 blah 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 equals the cosine of b. So now, if we want just angle B, what do we need to do in our calculator? Say what? Inverse cosine. So we need the inverse cosine of the answer that I have in my calculator. So that angle B is 16.53 degrees. It's quite the process to go through, isn't it? Yes. Yep. Don't know where the 3 came from, sorry. So now we have only angle C left to find, okay? And that's the easiest, right? Yeah.
Like, to find angle B, if you already found side A, could you just do side angle instead of side angle side? You already.
Okay, so Caleb is asking, basically, do we have to use a lot of cosines to find angle B, right? That's your question? Okay, once we find angle A, or excuse me, side A, could we say, well, we have 2 sides and an excluded angle, I could set up the law of sines. What do you think? Could we have done that? Yes, we could. Okay, now, let's find angle C, and then I want to go talk about that. Okay, does anyone have angle C for me? 108? Okay. Caleb, yes, you can. Now, first of all, let's look at this triangle. Does this triangle make sense? Biggest angle across from the biggest side, smallest angle across from the smallest side. Okay? Now, the issue with switching to the law of sines is that side-side angle is what? It's the ambiguous case. Okay? Now, the given information of side-side angle is the only time you're going to have two triangles, okay? This set of given information, side angle side, there's only one triangle. So here's the issue. If you would have found angle C with the law of sines, you would not have gotten 108.46, okay? We have the ambiguous case because the inverse sine has a range of negative pi over 2 to pi over 2. So negative 90 degrees to positive 90 degrees. There is no way for us to get an obtuse angle using inverse sine in our calculator, which is why we have that ambiguous case. The sine is positive in both the first and second quadrant. Okay? So the law of sines will not give us an obtuse angle unless we use the ambiguous case. All right? So this is what you would have had to do. If you would have found angle C using the law of sines, you would have thought, something's a little weird with my triangle. I think I need that angle to be bigger. You would have had to find its supplement. Okay? Now, ways to avoid that. All right? We know that C is the biggest angle. Let's not use the law of sines to find it because there's only one obtuse angle, if at all. Okay? Let's use the law of sines to find the smallest angle and then the rule of 180 to find the third. Okay? I do not mind you switching to the law of sines, but do not try to find an obtuse angle with the law of sines. Essentially, don't find the biggest angle if you're going to switch to the law of sines, because law of sines will not give you an obtuse angle. Okay, so let's look at our second example, and maybe instead of going through all of this work for, the second piece of information, maybe let's look at switching to the law of sines in the second example here. So go ahead and write this one down. Okay, the set of given information. The set of given information is what, Andrew?
Side.
Side. That's like the easiest one to figure out, right? We have all three sides. Even without drawing a triangle, we know we have all three sides. Okay. So we need, our only option is to find an angle, okay? When we had this side angle side case, our only option was to find that third side. Well, here we have all three sides. We get to pick which angle we want to find. Now, given the discussion we just had, I want you at your pod to think about and discuss which angle is going to be best to solve for first using the law of cosine. Go ahead and check. Come up with which one and why. Who votes for angle A? Angle B? Angle C? Okay, overwhelming choice of angle A. Okay, Eli, why did pod 1 decide on angle A? Because it's the biggest. Okay, so if there's going to be an obtuse angle, it would be angle A. All right, so if we in the future want to switch to the law of sines, if we find our biggest one first, we don't have to worry about thinking about the ambiguous case. All right, so we want to solve for angle A first, which means we need to write 34 squared equals 20 squared plus 18 squared minus 2 times 20 times 18 times the cosine of A. Okay, carefully with your order of operations. everyone in their calculator, I want you to work on getting to what angle A is. When you get an answer, compare it to your neighbors. Okay, so I'm going to run and check everyone's table. 126 point what? Okay, the biggest challenge with the law of cosines is your order of operations. Okay, you will know your order of operations. Just please be careful when you're using your calculator. Okay, so now we have found the obtuse angle. There is one, we found it. So now switching to the law of sines, no big deal. We're not going to have any issues. Okay, so now if you want to find, I don't know, angle B, we can take the sine of angle B over 20 and set it equal to the sine of 126.87 over side A 34. Okay. So similar to what we did Friday, right? We're going to have to take the sine of 126.87 and divide it by 34. That's what's on the right side of my proportion. We can multiply that 20 over. We get the sine of B equals 0.47 blah, 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 blah. So please be careful. Make sure you're pressing inverse sine now that we switched to the law of sines. To get that angle B is 28.07 degrees. Nick, did you disagree with something? What does that leave for angle C? 25.06. I like the law of cosines because it's very straightforward, okay? But the law of cosines is definitely messier algebraically, Okay? So if you don't want to worry at all about potentially having to use that ambiguous case to get the obtuse angle, think about the angles that you're finding, or just stick with the law of cosines the whole time. Okay, you have that ability to make that decision. Okay. All right. We have an area formula for side angle side. I'm also going to teach you an area formula for side side side. Okay. Let's say we don't know any of the angles. We know it's not a right triangle, so finding the height is a challenge. Okay. If we have all three sides of a triangle, and I don't know why they call big S area, but that's what it is. All right. So if you just want to write area, that's fine too. Area is this. So this is Huron's formula. When you come up with a formula, you get to name it after yourself. So in Huron's formula, you have to find little s, half of the sum of the sides. Okay? Then, to find the area, you take the square root of s times s minus a, s minus b, s minus c. So s times the difference from the three sides from s. Okay? So we're going to do one example, and then I'll send you on your way. Okay, my one example is when our triangle has sides of 43, 89, and 120. Our three sides are 43, 89, and 120. Okay, so we're given all three sides. So the first thing we need to find is little s. Little s is half of the sum of the three sides. Which is what? 126? Okay. So our area would then be this big long square root of 126 times 126 minus 43 times 126 minus 89 times 126 minus 120. Okay? I would not take the time to figure out what 126 minus 43 is and 126 minus 89. If I were you, I would type it verbatim what you see right here. Open that radical, use 126 parentheses, 126 minus 43 parentheses. Just type it in exactly like that. It'll save you time and potentially making an error with your subtraction. These sides are fairly large, so we're going to have a pretty big area. Tegan, do you have the area calculated? No? Okay. Go and type it in your calculator. Okay. I know that this seems like, I can do this in my calculator, but I want you to practice in class so you at least have that confidence going into your homework. Okay? Kira, did you find it in your calculator?
Yeah. 6,982.48.
It seems really big, doesn't it? Those you got? Did it get closer to 1,500?
Yeah.
Okay, so let's check your calculator here. So we should have square root of 126 times 126 minus 43 times 126 minus 89 times 126 minus 120. There we go. Okay. So our area instead, whoops. $1,500. I don't remember the rest. Point what? 7, 0. Okay. And that would be square units, whatever the units were. All right. Okay. You have a homework assignment and a quiz in 2 days. So you have your homework assignment this evening. Tomorrow, we're going to spend some time working with both law of science and law of cosines, making the decisions, okay, which one do I need to use? And then Wednesday is our quiz, okay? Will I give you these formulas? No, I won't. Okay? I will not give you